Hello friends. In this video, I will continue the topic of interesting and useful ways to use ESP32 controllers in a home smart home system. In the previous video, for those who have not seen it yet, the link will be in the description. I explained how, based on the Seeed Studio XIAO ESP32-C6 controller, you can make your own Zigbee sensor, and not just replicate some ready-made device, but assemble exactly the kind of sensor that does not yet exist in a factory-made version. In this video, we will continue this topic, but the use case will be different. Right away, I should note, the ESP32-C6 model itself is not mandatory here. Another ESP32 controller will also work for this task, because we will use standard Wi-Fi and Bluetooth interfaces. Zigbee will not be involved in this project. But since the kit I showed in the previous video included 3 such modules, for this example I will again use the Seeed Studio XIAO ESP32-C6 mini board. To explain the essence of this use case, I need to refer to 2 more of my videos. The first video was dedicated to the HumsiENK battery rated at 12 volts and 320 amp hours. In it, I showed its disassembly, testing, and connection to Home Assistant. And it is the connection to Home Assistant that is the key point here. The second video was about creating a backup power system based on this battery and a 2 kilowatt inverter. Links to both of these videos, as usual, you will find in the description. The problem is that Home Assistant can see data from this battery's Bluetooth BMS only when the battery itself is close enough to the smart home server where the Bluetooth adapter is installed. If you move the battery to the far corner of the room so that at least some obstacle appears between it and the server, the connection already becomes unstable. And if you move it to another room, behind a wall, the connection disappears completely. As a result, the integration in Home Assistant remains. The device seems to be there, but all the main sensors become unavailable, and it is no longer possible to get up-to-date data on the battery. The simplest solution to this problem seemed to me to be the use of Bluetooth Proxy. This is one of the standard ESPHome scenarios that essentially makes it possible to create a Wi-Fi extender for Bluetooth devices. The logic here is simple. The ESP32 module itself is located next to the battery and receives data from its Bluetooth BMS. And then this data is already transmitted to Home Assistant over Wi-Fi, meaning that the smart home server no longer needs to directly reach the battery with its Bluetooth adapter. Moreover, I still had 2 unused ESP32 modules left from those I'd bought a little earlier. And once again, I emphasize, for this use case, it is not necessary to use exactly the XIAO ESP32-C6. Another ESP32 controller will also do. For this project, we will once again need ESPHome Builder. As you can see, since the previous review, its interface has been slightly updated, because a fairly major ESPHome update has been released, and from here on we will be working with the current version. Here I already have 1 tile. This is the Zigbee sensor from the previous project. Right now it is shown offline, because I deliberately turned off its Wi-Fi interface. It is not needed in this project. And for Bluetooth Proxy, we will create a separate device. Click the button, Create a new device. Next, the configuration creation wizard opens. Here we choose to create a new ESPHome project from scratch. At the next step, we select the board. Since in this project I am using the Seeed Studio XIAO ESP32-C6, in the filter I choose the ESP32-C6 family, after which I find it in the list. The model can also be changed later in the firmware code. Next, we set the device name. I will call it simply Bluetooth Proxy, so that in ESPHome and Home Assistant it is immediately clear what this module is used for. If necessary, the name can also be changed later in the configuration. After the wizard is completed, a new Bluetooth Proxy device tile appears in ESPHome. For now, it is shown offline. Open the created device for editing. The wizard has already prepared the basic configuration: device name, ESP32-C6 board, ESPIDF framework, API, OTA, Wi-Fi, and a fallback access point. This is the starting YAML, which now needs to be slightly refined for the Bluetooth Proxy task. In the Wi-Fi block, I immediately add 2 parameters: power_mode, none, and fast_connect, true. The first disables Wi-Fi power saving so that the connection is more stable. The second speeds up the connection to a known network. For a device that must constantly transmit data to Home Assistant, This is quite logical. Next, we add the main part of the configuration, ESP32-BLE, ESP32-BLE tracker, and Bluetooth Proxy. These are the components that turn the ESP32 into a Bluetooth proxy for Home Assistant. I also add a reboot button and 2 diagnostic sensors, Wi-Fi signal level and uptime. They are not mandatory, but convenient for monitoring. You can immediately see how well the module maintains the network and how long it has been running without reboots. After making changes, be sure to run the configuration check with the Validate button. ESPHome builds and checks the YAML, and if everything is done correctly, we get a message that the configuration is valid. That means we can proceed to flashing the board. Click Install, and ESPHome offers several upload options. Since this is the first firmware installation for the new device, and it is not yet available over the network, we choose the option to flash via USB from this computer. ESPHome starts building the firmware. At this stage, it compiles the project with our configuration, Wi-Fi, API, Bluetooth tracker, Bluetooth proxy, and diagnostic entities. We simply wait for the process to complete. The build has completed successfully. The firmware is ready. Now ESPHome offers to open USB flasher. In principle, everything is very similar to what it was before, but some aspects have been made a bit more convenient. The ESPHome page for USB flashing opens, and the firmware file for the device has already been passed here. Now connect the module to the computer via USB and click Connect and Install. In the prompt that opens, select the port. Next, the firmware installation starts. ESPHome uploads the prepared file to the controller. The process takes a couple of minutes. Everything has completed successfully. The proxy is ready to work. We return to ESPHome Builder. Now the Bluetooth proxy device is already shown online. That means the board has connected to Wi-Fi and is available on the network. To verify this, let us open the device logs. In the logs, you can see that the module has successfully booted, connected to Wi-Fi, received an IP address, and established an API connection for Home Assistant. The Wi-Fi signal level and service information for Bluetooth proxy are also displayed here. At this stage, we can assume that the firmware itself and the network connection are working correctly. Home Assistant automatically discovers the new ESPHome device, Bluetooth proxy. It appears in the list of discovered integrations. Click Add. When adding it, Home Assistant requests the ESPHome API encryption key. We take this key from the ESPHome Builder page, 3 dots on the device tile, Show Key, copy it. At the next step, you can assign a device name and, if necessary, choose an area. I leave the name clear and simple, Bluetooth proxy. After adding it, the device page opens. Here you can see that Bluetooth proxy is connected via ESPHome. There is a reboot button, diagnostic sensors Wi-Fi RSSI, and uptime, as well as the connected device itself. Now I move the board directly next to the battery, which is located at a distance from the Home Assistant server. As I showed earlier, from this location the battery is not automatically detected because the signal from its Bluetooth BMS simply does not reach the server's Bluetooth adapter. For now, for testing, I power the ESP32-C6 from a regular power supply through a wall outlet. The task right now is not the final power setup, but to test the operation of Bluetooth proxy itself next to the battery. And here is the result. I did not reboot anything, did not remove anything, and did not add the integration again. I simply turned on the Bluetooth proxy next to the battery, and within about a minute the data and Home Assistant updated. All the sensors that had previously been unavailable returned to normal working condition. Charge, voltage, temperature, current, battery status, and diagnostic parameters are all displayed correctly again. Now for the final power option. For it, I used a small DC-DC converter board that I had bought earlier for my experiments. It is connected to 12 volts on the input and provides 5-volt USB power on the output. If I am not mistaken, the current here is up to 1 amp, which is more than enough for such an ESP32 module that I wrapped the board in heat shrink tubing and connected it directly to the battery, right to the inverter input. The power consumption of such an ESP32 proxy is very small, especially compared to the capacity of this battery. So for such a backup power system, this should not create any noticeable problems. As a result, we got a fairly convenient setup. The battery's Bluetooth BMS has effectively turned into a Wi-Fi accessible BMS for Home Assistant. The Bluetooth signal itself no longer needs to reach the server. It only works over the short distance to the ESP32 proxy. And then the data is transmitted over Wi-Fi, meaning the battery can be used at any point where there is stable home network coverage. And this is the battery voltage graph that I recorded the next day. Here you can clearly see what was happening with the connection. In the left part of the graph, where two white arrows are marked, there is a large gap. That is exactly the moment when I moved the battery to another room, and it lost connection with the Bluetooth adapter of the Home Assistant server. Then you can see a short appearance of data. That was when I connected the ESP32 proxy temporarily, powered by a regular power supply. After that, there is another small gap when I was already reworking the power supply into a permanent version powered from the battery itself. And, as can be seen from the graph, there are no more interruptions. The ESP32 is running directly from the battery. The Bluetooth proxy is located next to the BMS, and the data is transmitted to Home Assistant steadily. The gradual voltage drop here is also normal. The battery is slowly self-discharging, and the voltage decreases literally by hundredths of a volt. As a conclusion, as we can see, the operation of creating a Bluetooth proxy itself is quite simple, and the cost of such a board is only a few dollars. At the same time, such a small upgrade makes it possible to work with Bluetooth devices at a much greater distance from the Home Assistant server, without worrying about whether the signal will reach its Bluetooth adapter. The main condition is that there must be stable Wi-Fi network coverage in that location. The use case with the battery BMS is probably one of the most in demand. Quite a lot of battery systems transmit data specifically via Bluetooth and are at the same time directly supported by Home Assistant integrations. The problem is usually precisely the connection range. Bluetooth does not always pass confidently through walls and over long distances. But of course, this applies not only to batteries. There are other Bluetooth devices that can work normally near a phone or adapter, but lose connection if they are in another room or behind several obstacles. In such cases, ESPHome Bluetooth Proxy can become a simple and inexpensive solution to the problem. That is all for now. I hope this video was useful and interesting for you. I would be grateful for your likes. They help promote the video on YouTube. If you do not want to miss new reviews and tutorials, subscribe to my channel. In the description under the video, you will find all the necessary links to the devices shown, to reviews on this topic, as well as to my social networks, Telegram channels, and groups for discussing smart home issues. Join us. It will be interesting. Thank you for your attention. Until next time, peace to everyone.